Here I'm presenting the motorized notch making machine for FNCT test according to ISO 16770. As you know, the old standard doesn't specify the speed of the notch making. That's why in the past we use manual notch making machine for samples of FNCT test. Now it has the speed of movement for the notch cutting device. I mean, the speed of the notch making is defined. It should be less than half millimeter per minute. That's why you need an automatic motorized machine that can adjust the speed of the movement of the notch, the notching device. I mean the knife. That is a specific type of blade. Here you have two mechanisms here for the grip of the sample piece. This sample is 10 by 10 millimeter, and the length is 100 millimeter according to the ISO norm. Here you have a stopper. You can easily loosen this screw and set the placement of the sample piece in the middle. It's a stop for the sample piece. You will be able to adjust the knife cutting the center of the sample piece. When you put the sample piece here, you have one gripper section. It grips the sample piece. You will put the sample piece here in contact with the end stopper. Before you will adjust the end stopper position to have the notch exactly in the center of the sample piece in length. Then you will grip the sample using this handle. Using this wheel, you will be able to tighten the sample piece. Then you have the spacer here. You will put the spacer here like this. Then I'm bringing the sample piece in contact with the razor blade. Put the spacer here. Yeah, for the starting position. For the correct position of the razor blade in contact with the sample piece, not to cut it in the starting position, you need this spacer. Now this spacer is just being put here. Be noted not to apply any pressure on the sample piece to have the notching on the starting position of the razor blade. I'm putting it here, turning this wheel slowly. Yeah, don't apply any force to the sample piece while you are moving the sample piece. That is the starting position to start the notching. That's all. You see, I can freely release the stopper. Yeah, I can easily release the stopper from here. This is the starting position, and the razor blade is in the contact, zero contact with the sample piece. Then release the stopper, the spacer, and now we are ready to start the notch making process. On the indicator, here we have a stepper motor, a gearbox with a ratio of 5. That's why for having the higher resolution and notch making depth on the razor blade side, we have a multiply factor of 5 to the depth of notch. I mean, when you want to set the depth of notch, you will press this wheel hold it, then turn the wheel. You will have the forward movement of the knife. Now it is 8,000. 8,000 divided by 5 will be 1,600, and it means 1,600 micron. That is 1.6 millimeter. This setting for this F2 parameter is a setting for the forward movement of the razor blade, and when it says 8,000, it means divided by 5 will be the depth of the notch in terms of micron. When you divide it to 5, the value will be 1,600, and it is in terms of micron, the depth of notch that you will make on the sample piece. I mean the forward movement of the knife. When you go to the here, when you go to F3 is the speed of the forward movement. You can change the speed as you request. F4 is the backward movement of the knife after cutting the notch on the sample piece. It will backward with this distance. This distance also means with the multiply factor of 5, this 8,000 meaning 1,600 micron. And the speed of the backward movement is being set here, and it is 5. Also in the 5, this value is in terms of, for example, when I'm coming to F3, that is forward movement speed. When you want to change it, I'm setting it to click one more time, reduce it to 0.5. This value also has the multiply factor of 5. When you set it to 0.5, it means 0.1 turn per minute. 0.1 turn per minute. With the pitch of the screw, the pitch of this screw, of the ball screw is 5 millimeter. When you are setting the speed of turning for this screw to 0.1, it means the speed of movement of the knife will be 0.5 millimeter per minute. I'm repeating again. The pitch of the screw for the movement of the knife, the blade, this ball screw, just moving the holder of the razor blade, and the pitch of this ball screw is 5 millimeter. When I'm setting the speed of turning here, F3 parameter, forward movement speed of the razor blade to 0.5, it means real speed of turning of this ball screw will be 0.1 turn per minute. That means 0.5 millimeter per minute for the linear movement of the razor blade compared to the sample piece. That's why I'm setting here 0.5, that is the speed of movement, forward movement. And after setting, just click, push the wheel and hold it. It will be saved. Now the value of forward movement, I'm repeating again, just press and hold this wheel. You have a parameter of F2, that is forward movement. This is 5 times the real movement for real forward movement in terms of micron. The real value will be 1,600 micron. The forward speed will be 0.5. That is 0.1 turn of the screw. With a pitch of the 5 millimeter, it means 0.5 millimeter per minute for the speed of the movement, forward movement. For the backward distance is parameter F4, that is the same value. The other one is F5, and the speed of the backward movement is 10 times the forward movement for finishing to finish the process of the notch making sooner. After setting these parameters, you will push and hold the wheel. Yeah, and click stop. When the motor moving clockwise, you have this LED on, and the backward will be the counterclockwise turning. Now we are ready to start. After setting these parameters, you will come here and set the sample piece. As I showed you, you will grip the sample piece here, set the end point, contact point, then turn this wheel to hold the sample piece in place. Push the spacer, put the spacer here, turn this wheel, put the spacer here. After you have the contact here, don't turn it, don't apply pressure on the spacer so that you can be able to release the spacer easily. This is the 0 point of the movement of the razor blade compared to the sample piece. Then we are ready to start the movement. You will run. You will push the key run here. Now it turns clockwise. Starts movement to make the notches with the depth of 1.6 millimeter with a speed of 0.5 millimeter per minute. The speed of movement is very low, and for you to see that, or to be able to calibrate the movement and to see the real movement of the razor blade compared to the sample piece, you have also this machine now is making notch. I'm opening it. You have a place here for putting the micrometer. The indicator can be assembled here. You will loosen this screw. You will put this indicator here to be able to calibrate. Let's finish this notch making process that we already started notch making to make a notch on the sample piece. The depth of notch is 1.6 millimeter as I showed in the video. And when the LED of clockwise is on, it means that it's still moving forward with the very low speed of 0.5 millimeter per minute. You need to wait. After finishing the depth of notch, it will move backward automatically to the origin position of the knife. We are waiting for 2 minutes, and after that, after the notch making finished, I will come back to you because it will take about 3 minutes. I mean 1.6 millimeter, meaning 3 or 4 minutes, 3.5 minutes for the notch making process. I will come back to you after the notch is done. Okay, now when you in the starting position of the razor blade, when you push the key run and stop here run, just push one time, it will start automatically clockwise. Going in, the razor blade will go into the sample piece, and after going with the distance as we set here, the distance as I said is here, the parameter F2. After passing 1600, as I said, this has multiply factor of 5, and the real movement will be 1600 micron. After going this distance, it will go back automatically with this setting of the F4 parameter. This has also the same multiply factor of 5. I'm pushing this wheel and it's done. I'm just showing you the notch on the sample piece. You see the notch here? Yeah, here we have the notching done with that speed. Yeah. Okay, now I'm going to show you the real movement. That's why I'm going to use this indicator. This is not a standard delivery with the machine. You can use any kind of standard indicator, and okay, you can use any kind of indicators. The resolution of this indicator is 1 micron. You just open the screw here. Now I want to show you how to verify the movement of the razor blade carrier here. As I said, forward movement here is in the parameter F2. Just push the wheel, hold it. You will come to F2. This is forward movement, and the real movement will be this value divided by 5. That is 500 micron. It means 0.5 millimeter of the movement for the razor blade. And F4 parameter is the backward movement, will be the same as the forward movement, that is 500 micron. I'm just pushing this wheel to come back to the main menu, and now I'm clicking this indicator to 0, and here I'm starting to see for the 0.5 millimeter how much distance the razor blade holder will be moved compared to the back support of the sample piece. I started, and the speed of movement is about 0.5 millimeter per minute. As you said, the speed of the as you see, the speed is around 0.5 millimeter, the real speed of the movement. Also, you can verify it using a stopwatch with the movement distance. This value is in terms of millimeter. You can calculate the real speed of the movement using a stopwatch and this indicator. Yeah, you see, the real movement value was 485 micron, and you can readjust the movement using this parameter. You can change the real movement here to increase the forward movement and backward movement as it needs. Also, for the verification of the notch depth on the sample piece, you can also use the microscope as standard says. As I said, this indicator is not standard delivery. It's a general purpose indicator. You can order it separately, or you can use your local brands for the micrometer indicator, and you can mount it here for verification of the movement. For the replacement of the knife, as a standard says, after the 10 sample piece prepared with a razor blade, you need to replace it. Replacement is easy. The dimension of the thickness and the geometry of the edge is according to the standard. You can replace it opening this holder. Use this an Allen key to open the holder of the razor blade, and using these 2 screws you can put another blade in the holder and tighten these 2 screws. Yeah, tighten these 2 screws on 2 sides of the razor blade. You can easily hold it tight. Be sure that the blade is fully tight in place. If you do it correctly, the distance, the edge of the knife that is outside of the holder is about 3.45 millimeter. This much, the spacer that you're using when you put the spacer here. Yeah, in contact with the holder tip. Yeah, you see it's the distance of the notch outside the holder is the same as this distance that we are using as the spacer for the 0 point adjustment of the razor blade compared to the sample piece. It's easy to use, it is automatic, it is according to the standard, the motorized automatic notch making machine from AHP Plastic Makina. Thank you.